Namaskar. I am Dr. Aarti Chaudhary, Assistant Professor in the Department of Ancient Indian History, Culture and Archaeology at Vasant Kanya Mahavidyalaya, Banaras Hindu University. I welcome you all in this 12-week course titled History of Science and Technology in Ancient India from Harappan Civilization to 7th Century CE. And today we are going to discuss Module 4, Lecture 5. The title of Module 4 is Iron Age Culture and title of today's lecture is Iron Technology. We have already discussed about the origin and development of iron, the role of iron in urbanization process, the archaeological and literary findings which is based on iron, the position of iron in South India, the association of iron with black and red ware culture and megalithics. And now we are moving towards the iron technology. What are the methods or technology was used by the ancient people in iron? How the iron metal and metallurgical activity done by the ancient iron workers or metal workers, we will discuss it in this lecture. So let's start. The learning objective of this lecture is to know what is carburization, to analyze the process of quenching and tempering, and finally the understand the techniques used in ancient India to produce high quality wood steel. So we will discuss it in this lecture. The highlighted point what we will discuss here, that is iron in ancient India, carburization process, smelting and furnaces which recorded from the iron age site, the process of quenching and tempering, forging and tool making process, wood steel, and the peerless example of Indian iron metallurgy like iron pillar, Mehrauli in New Delhi and Dhar pillar in Madhya Pradesh. The advent of iron technology revolutionized ancient Indian society, enhancing agriculture, warfare, and craftsmanship. Archaeological evidences trace its use back to the early first millennium BCE, with smelting and forging techniques evolving across regions like the Upper Gangetic Valley and southern India. Ancient texts such as the Rigved and Yajurved reference metal extraction, underscoring India's advanced metallurgical knowledge. This presentation explores the key iron production techniques of ancient India, highlighting their innovations and lasting impact. So, the key points are iron technology revolutionized ancient Indian society. It enhanced multiple sectors like agriculture sector, warfare, and craftsmanship. The iron technology, iron metallurgy just boosts these fields. In archaeological evidences uh, date to the early millennium BCE, regional development in Upper Ganga Valley and southern India, textual references in Rigved and Yajurved indicates establishment established metallurgical knowledge as well. The presentation explores production techniques and their lasting impact. So, the iron in ancient India, which is divided into three parts: wrought iron, no carbon, little or no carbon present in this wrought iron. Second one is casting iron, up to 7% of carbon present here in this iron, and still up to 1.7% carbon present this steel which is basically the iron property. Different types serve various functional needs based on their properties. And the carburization process. This process is important in iron technology. Heat treatment, initiation, then carbon diffusion, then surface enrichment, enhanced hardness, improved wear resistance, and then core toughness. If you want to understand this, then the points are: in carburization process, the heat treatment process for iron enrichment, then carbon diffusion into the iron surface during heating results in surface hardening, hardening while maintaining core toughness, enhances wear resistance and durability as well in the particular metal, and the process developed for specialized tool and weapon production. Basically, the carburization process just give the harden, it make iron much harder than before. In this technique, a chemical and spectroscopy analysis of 6 objects from the Rajghat excavation dated 600 to 400 BCE conducted by Bharadwaj revealed varying levels of carbon content ranging from 0.12 to 0.42%. The relatively low carbon percentage suggests that these objects underwent natural carburization during the forging process. However, one object exhibited a significantly high carbon content of 1.1%, indicating that it was initially carburized to enhance its properties. Then the carburization process is very important in terms to get much harder iron. In Rajghat excavation, here is the example of different metal tool of the carburization which have the carburization process, and from Rajghat excavation that is 600 to 400 BCE object contains 0.12 to 0.42% carbon. One specimen with 1.1% carbon suggests intentional carburization, and Varamihir in 550 CE documents carburization and hardening techniques for swords in Kharaglakshanam, and in Komaranhalli, iron spear with 0.24% carbon layer, date is 1200 to 1100 BCE. Tadkanhalli, iron X with 0.30% carbon layer, date is 1000 BCE. Barudi Singhbhum, carburized iron celt showing pearlite structure, date is 1200 BCE. And from Alamgirpur, evidence of surface carburized iron is in painted gravure phase. So, the process of carburization is showing that the metal worker know the activity from which the carburization process will perform, because they know by this process the iron would much harder. This slide show the process of smelting and furnaces, overheating, then melting point reached, then melt separation, and melt metal obtained finally from the cube. And the process is overheating to reach melting point, like the ore must be in the particular temperature for the smelting or heating process was done correctly or significantly. Metal separation from impurities, it is just it is very necessary. If we want to just separate the impurities, then metal should be separate from that ores or that impurities by the process of heating, and the process enable production of workable metal, foundation of iron production technology, and essential pre prerequisite of all iron manufacturing. Now, I have to draw your attention towards the furnaces because iron needs much more higher temperature for to smelt or to heat. So the furnace, the structure of furnace and the temperature maintained quality by the ancient metal worker is also very important. A high temperature heating chamber or structure is necessary uh, for the melting, smelting, processing metal, glass, ceramic, anything. And types of iron smelting furnaces in ancient India is bowl shaped furnace, dome shaped furnace, and shaft shaped furnace. These kind of furnace, these kind of furnace shows their just their ability to select, to understand what kind of furnace is suitable for the different iron metal technique. And the evidence of furnaces and smelting, which reported from the different sites, they are the Naikun furnace remains of megalithic period in Vidarbha region, and furnaces recovered from Khairadi, a site in the Balia district, Uttar Pradesh, India, are examples of shaft furnace. Naikun is a major iron smelting site. At Noh and Jodhpura, furnace with a side hole were recovered in which the nozzle or bellows might have been inserted. Two furnaces have been discovered at Soneri in the Jhunjhun district of Rajasthan. These are of an open type and were equipped with bellows. Similar type of furnace was recovered from Ujjain as well. Evidence of smelting is recovered at Ujjain, where huge deposit of iron slag and is unsmelted molten iron ore, lumps or crystalline material identified as calcite or aragonite, and quantities of a whitish powder, probably lime, occurred in an exposed section, which points to a simple method of smelting employed at Ujjain. The furnaces used for iron smelting is also reported at Ataranji Kheda, which belongs to circa 1000 BCE, as well as the primitive methods of smelting iron ore and forging are practiced by the tribes of Agaria and Khuntia, Chokes, Marias, and Murais in Madhya Pradesh, Birs, Birjia, Agaria, Asur in Bihar, Gond, Telis, and Manevaras in Maharashtra. So, on the basis of these information, we can say the ancient metal worker, well known, well aware about the furnaces and smelting activity of the iron metal, and they made their furnace according to their demand of the different iron metallurgical aspects, as well as the different tribes still they are working in the same techniques because they are not associated with the main course of the society and they don't know about the different scientific discoveries regarding the smelting or forging or some another things related to the technological aspect. So they working as the ancient people worked, they just carry that legacy in the present world as well. So they are very important in terms to understand the iron metallurgy in ancient perspective for all of us. Evidence of furnaces, a few more informations are from Ataranji Kheda, iron smelting furnaces is 1000 BCE, No and Jodhpura furnaces with side hole or bellows inserted insertion. Suneri, Rajasthan, open type furnace with bellows similar to Ujjain furnace, Naikund, Vidarbha and Kharadi, Eastern India, shaft furnace for megalithic period, and tribal communities, Agaria, Khuntia chokes, Ashur, preserved primitive smelting techniques with them. These pictures show the furnace of the iron metallurgy. The bellows is present in the picture and the whole furnace, how they working how they worked regarding the ancient metallurgy of the ancient metal workers. This picture shows that. Now, quenching and tempering. These techniques are very important in iron metallurgy. Just look, understand this thing. Iron metals found from many archaeological sites. It is also mentioned in Rig Vedic text or later Vedic text as well. But when the technological aspects, technological evidences also reported from the different sites like metalworking workshop area, slags, the different tools which have the activity which proved that the quenching, the tempering activity was done on that particular metal, it shows that the metal technology was completely accepted and introduced and developed by the society, and the metal worker of ancient India were well known to the activity and they performed, and these knowledge will carry by the further societies what continues till the era. In quenching process, heated metal rapidly cool down. Quenching is also called sudden cooling because once the metal was in high temperature, it heated in high temperature, then it sudden cool in the normal water. So it is called quenching and it is called sudden cooling as well. Microstructure alteration and enhanced property, we will explain it in the next slide. And the process of tempering, quenched metal reheated under its critical point temperature, cooled in the room temperature, and superior strength and hardness and corrosion resistant. When quenching was done in a particular metal, then due to the sudden cooling, a short mark, stretch mark appear on the surface of the metal tool, and then by the hammer, the metal worker heat that particular tool and hammering on that particular stretch mark that show that can disappear on the surface. And this process will repeatedly performed by the metal worker, so it is called tempering process. You can understand this quenching, rapid cooling or heating metal typically in water alters microstructure to enhance hardness, and tempering, reheating quenched metal below critical temperature. Controlled cooling provides superior strength, hardness and corrosion resistance. Combined process create the optimal balance of properties. Evidence of quenching and tempering. Sickle with a sharp cutting edge from Pandu Raja Dhibi has a tempered marten stick structure and is considered to be the earliest quenching of an iron tool in India. Date goes back to 3rd century BCE. From Judge Mau, the chemical properties of the iron axe shows quenching and tempering techniques. Iron razor from Kangra, Himachal Pradesh shows massive fertile and martensitic plate which indicates rapid quenching. These examples are very important because it just give information regarding the technological aspect of metal. It means the people, the ancient metal people, just transform metal to the metallurgical aspect as well. This slide shows the iron forging and tool making, forge welding process, heat making, heating the metal, then applying compressive force, then shaping the metal. Methods of joining two metals by heating and hammering them together. Iron forging and tool making. Forging is heating metal and applying compressive force to shape it. Forge welding, joining metal through heating and hammering. Specialized technique developed for different tool requirements. enabled production of diverse utilitarian and military implements. Evidence of forging and tool making. Arrowhead and spearhead from Ujjain are amongst the early iron sample dated 750 to 550 BC. The surface hardness of the hoe reported from Dhatwa shows a forge welded laminated structure 550 BCE. Hunting tools include arrowheads, spearheads, dagger, swords, socketed tanks, etc., armors, horse by horse bits, and caltroop belongs to the later stage from 1st century BC to 6th century AD. Agriculture tools include axes, sickle, spades, plowshares, hoe, chisel, etc. Household objects include knives, nail, clamps, etc. The forge welding process was used to manufacture the iron pillar, Delhi, where lumps of wrought iron were heated and hammered together to form the structure. Wood steel, the advanced metallurgical example of Indian iron. Wood steel, also known as Serik steel, was a high quality Indian steel used for sword making and exported worldwide. The term woods likely originates from the Tamil word urukku or ukku. Around 300 BCE, wood steel became very popular in the Middle East for its superior hardness and sharpness. It was produced by heating black magnetite ore in the presence of carbon in a sealed clay crucible inside a charcoal furnace to remove slag. So, the presence of carbon in iron with the any tool in the form of any tool, sword, weapon, the presence of carbon is just give the sharpen or hardness to the iron metal any tool. Another method involves smelting the ore into wrought iron followed by heating and hammering. Bamboo and arawai leaves were the essential source of carbon. It is also very important that the not only the metallurgical aspect but the ancient people, basically the metal working people, were well known to the vegetation as well. That's why they find out some kind of bamboo tree, some kind of arawai leaves to generate more carbon for their this metallurgical aspect. These informations are really very important in terms to understand the science and technology, the advanced scientific and technological development during that particular time, not only in the metallurgical aspect as well as in the biological aspects as well as in the floral aspect as well. By the 5th century, Chinese and Sri Lankan blacksmiths adopted this technique from Tamil chairs. The Golconda region in Telangana became a major center to export to West Asia. Now, the information regarding Iron Pillar Mehrauli, New Delhi. This is unparalleled iron technology example of Indian science and technology in the world. The Iron Pillar of Delhi, dating back approximately 1600 years, is a remarkable example of ancient Indian metallurgy. The pillar weighs between 7 to 8 tons and stands 7.21 meter tall with 1.12 meter buried underground. It is composed of forged weld wrought iron, which has contributed to its extraordinary resistance to corrosion. The first detailed scientific analysis of the pillar was conducted by Sir Robert Handfield in 1912. Metallurgical studies have revealed that the pillar consists of 98% wrought iron and contains 0.15% carbon, 0.05% silicon, 0.05% manganese, 0.25% phosphorus, 0.005% nickel, 0.03% copper, and 0.02% nitrogen. The iron used in the pillar exhibits high phosphorus content 0.025% and extremely low level of sulfur and magnesium, which plays a crucial role in its corrosion resistance. Additionally, the presence of a thin protective layer of magnetic oxide further prevents oxidation by shielding the iron from moisture and oxygen. The next important and unparalleled exam of Dhar pillars from Madhya Pradesh. The Dhar iron pillar, 14 meter in height and 7 tons in weight, is an important example of ancient Indian iron technology. Located in Dhar, Madhya Pradesh, it is believed to date back to the 11th century CE during the Parmar dynasty. The Dhar pillar is made from a horizontal forge welding technique wherein smaller iron sections are welded together. The pillar exhibits remarkable corrosion resistance properties. The microstructure of the iron in the Dhar pillar revealed the presence of entrapped phyllite slag inclusion. The chemical composition of iron consists of 0.02% carbon and 0.28% phosphorus. The high phosphorus content contributes to its corrosion resistant property. So, on the basis of the technological terminology and the examples, we can say that ancient Indian ancient India demonstrated remarkable advancement in iron metallurgy, developing techniques that significantly influenced both domestic industries and global trade. The mastery of ironworking included processes such as quenching and tempering, which enhanced the hardness and durability of weapons and tools. The production of wood steel, a high carbon crucible steel known for its exceptional strength and flexibility, gained international recognition and was later used to forge the renowned Damascus blades. Additionally, techniques such as forge welding, carburization, and the incorporation of phosphorus for corrosion resistance were employed as evident in structures like the Iron Pillar of Delhi, which has withstood centuries without significant rusting. In agriculture, the introduction of iron plow and tools significantly improved farming efficiency, supporting economic and population growth. Trade also flourished with Indian iron and steel being highly shout after the regions such as Persia, the Middle East, and Europe. Furthermore, ironworking skill contributed to architectural and engineering marvels, demonstrating a deep understanding of material science. Overall, ancient India's iron technology was a pioneering force in metallurgy, blending scientific precision with practical application. The advancement in heat treatment, forging, and corrosion resistance not only strengthened various sectors but also cemented India's legacy as a center of metallurgical excellence, influencing ironworking traditions across the world. So these are the basic reference which can helps you to understand the iron metal and metallurgy, their origin, their development, their connection to the other parts of world as well as in Indian different region. So you can consult it for your better understanding. for this topic. This is it for now, and we will meet in our next module very soon. Thank you very much for your patient listening. Namaskar.